Do you ever start a 3D print on your Creality 3D printer and come back to realize that it stopped extruding halfway through or even sooner than that? Well, I have an upgrade that I've been using for a while now that will make this a thing of the past. Hello everyone, Chris here, and yes, I know the title on this is probably pretty clickbaity, but honestly, we have done a lot of upgrades over the years on Creality machines. I've been using this style Hotend where the PTFE tube goes all the way down to the nozzle since I got my first CR10 back in 2017. And I think the most common issue that I see with these is how that tube interacts with that nozzle. Under extrusion is very, very common. And with this upgrade we're going to talk about today, I think this is the best fix for the money for any Creality printer. I think Creality as a company should just switch to this style and do away with the PTFE to nozzle mesh up altogether. But we're going to talk about all of that as we check out the Slice Engineering bimetallic Heatbreak. This is the Slice Engineering Copperhead CE Heatbreak. It is a direct replacement for a Creality style Hotend. It's designed to be the same length and size as the stock Heatbreak, only it's a lot higher quality part. So basically, all we're going to do today is upgrade the Heatbreak on this 3D printer. We're going to keep the hot end, the nozzle, the heat block, everything else will stay the same. And it's always my aim with these videos to make things as simple as possible. A lot of times in these industries, you start hearing terms getting thrown around when maybe they're not as complicated as they might seem. So that's what we're going to do today. I'm going to show you all of the stuff that I have learned by swapping out this brake, how this might affect you, the different conditions that it's going to solve for, and I also wanted to mention that Chuck Hellebuyck and Stefan over at CNC Kitchen have great content on this exact modification. I will leave a link to their videos, but remember what I always say, if you have content, doesn't matter if somebody else did it, you're going to do it a completely different way. So that's what I'm going to do now. Let's dive into the Heatbreak itself and see why we might want one. So what's so special about this part and why does it work so well? Well, you're going to hear the term thrown around, bimetallic. All that means is they've used two different materials to build this. The outside is copper, and then there's a stainless steel tube inside. The copper helps you get that heat into the block and into the heatsink where it should be, so the hot side stays hot, cold side stays cold. And the stainless, because it's so thin, it keeps the heat from transferring from the cold side to the hot side, eliminating heat creep. Also, with a design like this, you can get to 450C if you wish, because it removes that PTFE all the way down to the nozzle. You can see in this end, it does allow for that PTFE tube to go down inside the brake, but just enough to give it a smooth transition. It doesn't change it completely, so you can still push it down in there like the stock setting, but it's nowhere near the nozzle at this point. And that's what makes it such a great upgrade. If you're going to do this modification, I do recommend you go ahead and grab some Boron Nitride paste. It's just going to make this modification even better. It makes things more conductive so you can get that heat into the block and into the heatsink where it needs to be. It also can help when releasing your heater or your thermistor cartridge out of the block. Sometimes they do tend to seize. This can help with that as well. So there's a look at what we're dealing with here, and it's a lot more simple than you might think. Basically, it's a copper heat break with a stainless steel tube in the center. And we always have to talk about price. These brakes are around 30 bucks. They're built here in the US. But if you have a problem on your 3D printer, it's definitely going to be a lot more affordable to swap out this brake than it is going to be a Hotend. And it's pretty much going to solve all the problems that a new Hotend would and allow you to print at higher temp. So now let's dig into the meat of this thing and get our printer unassembled so we can start this upgrade. And the upgrade is very straightforward to do. We'll just remove the fan shroud here. It's just this screw here on top and then one over here on the left side. Then that'll swing out of the way. Mind your wires. We don't want to change any of the wiring up. And then from here, we want to preheat the hot end so we can remove the nozzle. You can go ahead and take off the sock if it'll come off. And we want to soften up any filament that might be in there so we can pull out the Boden tube. Once you're up to temp, you might want to go ahead and use some pliers. Even though these do have the screws holding that block in place, you might want to go ahead and hold it anyway. But hang on to that block and then back your nozzle out. Once the nozzle's out, you should be able to push down on the coupler and release this Boden tube. Be careful, this is up to temp, it's pretty hot, but it makes it a lot easier when it's hot to get it out of here. If you can't get the Bowden tube out, if it won't pull out, try to push it through a little bit now that nozzle is removed and then pulling it out, just to loosen its grip the coupler has on that tube. Our tube is out, and before I let it cool off completely, I'm going to go ahead and remove the hot end. Remember, because the fan isn't on here, this heatsink could get pretty warm. You want to watch your fingers. And when it's loose, I grab it with a set of pliers, and the reason why I leave it warm is because of these two screws underneath. These come through the block and go into that heatsink. So at least loosen these up before you turn the printer off. When it's warm, they should be pretty easy to back out. And depending on how gunked up your heat block is, you might want to go ahead and loosen up the thermistor screw and the grub that holds the heater in. This one doesn't look too bad, but it probably wouldn't hurt anything to go ahead and do that. So I'll loosen up this grub screw. And when that heater's loose, I'm just going to go ahead and turn off the printer so it'll start cooling down. And it'll be plenty warm enough to go ahead and back out this thermistor screw. Now you should be able to get the heater and the thermistor out relatively easily. Again, if your hot end isn't too gummed up, you should be able to back these out relatively easily. There's our stock heat block and brake. Now you should be able to just back that brake out. It's just threaded into the top of the block. Everything's apart. Now is a great time to go ahead and clean up your block, do any maintenance that you need to do before we reassemble. You can do whatever you want with this stock brake. So since we're interested in the most cost-effective mod possible, we're going to go ahead and reuse everything stock except that new heat brake. So first thing I would recommend is cleaning up your heat block as best you can. Heat it up if you have to. I actually clean out these threads with an M6 tap because you don't want to put any added force on that brake. Remember, this brake is just pressed together. It's copper on the outside. In fact, you can see it on my finger here. It's really easy to mar, but it's just copper with a tube pressed in the center. You can separate it if you try hard enough, but don't do that. So what I do is I just put some paste, some boron paste, in the threads for the brake. You don't have to put on very much. You'll have to clean the excess off later. I also put just a little bit in the screw holes here. It can't hurt anything, and it would help you separate them if you ever need to pull it apart. And it's not going to matter a whole lot on this heat block design, but I go ahead and put just a little bit in the threads for the thermistor and the thermistor hole, and then some in the heater as well. Again, it doesn't need very much. The heater and the thermistor, it's going to push it out, but it's just enough to give it a coating. And then we can go ahead and start assembling. So on your brake on the top of the block, just thread it in. Again, be very careful. You want it about right there, just so you can see some of that top thread hanging out. And then you can go ahead and put your nozzle on hand tight for now, just to keep that brake in place. And you'll know you have that brake in there when there's just a little bit of gap in between that block and the nozzle. I should have cleaned my nozzle up just a little bit better than I did, but it'll still work. And then on the heatsink side, I'm going to go ahead and put a little paste in here as well. Remember, this is to help transfer that heat into the sink so that it works better. It's more efficient to pull the heat away. This is the cold side. And it's going to slide in just like that. It'll go all the way up here to the top, and it'll be flush up here. It's probably worth pulling your coupler off just to make sure that there's none of that paste inside there. If it is, get a Q-tip or something to clean it up. It's probably not the worst thing in the world. You could clear it, but it might cause you a jam. And also note where the thermistor and heater comes in on your Creality machine. Most of them come in from the right. And then you can go ahead and snug up this grub screw. Now, the nozzle being loose will give you a little bit of play on this block so that you can get these two screws lined up back in the heatsink. We can go ahead and put those back on. And there's no need to get carried away tightening those. You want to make sure that it doesn't pull that block one way or the other. Just snug them up. And then we can go ahead and put the thermistor and the heat cartridge back in. We can just slide in our heater. After you clean it up, it should be relatively easy to put back in. And I like to tighten up that grub screw before I tackle the thermistor, just so it stays in place. Then we can put that thermistor bead back in its hole. and put that mounting screw back on. Another screw that you don't want to get too tight because it will tear those wires on the thermistor. It just needs to be tight enough to push it down and make sure it doesn't come out of that hole. And then we can go ahead and mount it back on the printer. The Hotend's back on. You might want to go ahead and adjust the length of your PTFE tube. You don't want any more PTFE for the Boden tube than you have to have, but it'll just slide back down in here, go inside that heat break. Then you can clean up any extra boron paste and put your fan shroud back on. And our upgrade is almost complete, but here comes the hardest part of this whole thing. You really should give that boron paste about 24 hours to dry before you try to use it. You can do like temperature cycling from 0 to 70, or I think it's 70 to 100, somewhere in there. There's directions on the Slice Engineering site on how to do that, but I think it's just easier to leave it alone for 24 hours. So we'll be back. So while we wait for that to dry, let's talk about the conditions you might see on your Ender 3, how they happen, and how this part is going to help that. And just to make it easier to explain, I have printed out the awesome E3D V6 model that Flowillistic did years ago as just kind of a guide on what we're talking about here. So here's the model of the E3D V6. Now, the Creality style Hotend is going to be a little bit different, but this is going to be more than good enough to explain the scenarios we're seeing here. This is the typical setup that you would see for a V6. You're still going to have some PTFE tube to guide the filament down to the brake, but just to the top of the brake. And then from there, it's all metal down to the nozzle. And that's a pretty common setup. It works great. Sometimes PLA, it can be just a little bit sticky, but for the most part, it's going to work just fine. And you're going to eliminate a lot of heat creep because of the amount of the brake that's in the heat sink. Of course, you still do have to have a fan to pull the heat away, but a pretty good setup, and it's kind of been the gold standard for a long time. And if I can hold this just right, that's how your Creality setup's going to be. Your PTFE tube, your Boden tube, it's all the same thing. So you have a PTFE lined Hotend. It goes all the way down to the base of the nozzle. And if your tube is butted right up against that nozzle, it's going to work just fine. The brake inside that Creality Hotend, like I showed you before, it's just a very thin tube that goes around it. The PTFE is made to do the work. The problems come in when you want to do higher temp filament. This PTFE tube isn't going to be good to a lot of the higher temperatures. You don't want to push it much past 240 because it's going to degrade. As it degrades, it's going to constrict around the filament, cause all kinds of problems. And eventually it will wear out even at the PLA temperatures, and you're going to have to replace it. So that's one issue you can see with a setup like this. So the other issue that you can see on these is you have a Boden coupler up here on top of your Hotend on this Creality style. That's supposed to hold this tube in firm up against that nozzle. But that's actually a two-way coupler. So you push down, and to lock it in place, you would actually have to lift up on it just a little bit. So when you push it down in there, it might have the ability to move back and forth like this, just a little bit. And if that's the case, if you pull back from that nozzle just a bit, you're going to get a pool of filament right at the top of that nozzle, and that's not going to be any good at all. You're going to get jams, you're going to get that under extrusion like I showed you at the top of the video, especially when you come back to start another print. It's not always going to be able to liquefy that correctly and get more filament down in there. So that's not good. And there's been a couple of different community fixes to try to keep this from happening. The one that I see most commonly is to separate your PTFE liner for your Hotend with your Boden tube. So you'd cut a smaller piece, then you'd put a 3D printed washer or some type of washer up here, then you'd put your coupler on to smash that down to keep it right up against your nozzle. Then you would put your Boden side on the other side of that washer in your coupler, so if it wanted to move in that two-way, it wouldn't make a difference. You would just have that washer space in between here, but that coupler would keep the washer pushed up against the one in the Hotend, so you don't have that gap problem anymore, which is a pretty good fix. Also, the method that I usually end up doing, that seems to work most of the time, is when you load your PTFE tube, you swap it out, or when you're first building your printer, you will back your nozzle out about a turn. Then force the PTFE tube down to whatever gap that turn made, and then pull it back just a little bit to lock it into that coupler. After that, torque your nozzle, and that's going to smash the nozzle up against the end of the PTFE, just squishing it a little bit so that you have a pretty tight seal up against that nozzle. And again, it does work out. I've used that method many times without any issues. Also, the issues of heat creep are pretty easy to see on this model. If your fan wasn't pushing enough air, or if the design of your Hotend wasn't good enough to pull that heat away, you could see heat creep. Heat creep is when the hot side, this side, creeps into the cold side. This break here is supposed to be thin enough to keep that from happening on most Hotends. With that PTFE liner, you're kind of just hoping that that break can get enough heat into the sink to keep it away, but that PTFE tube is going to be able to lower temp, so that's going to help as well. But if there's something going on inside your Hotend, or that fan gets just a little bit weak, you are going to see heat creep, and that's going to cause a jam as well. So with that Copperhead Heatbreak, you have copper on the outside, so it's going to be able to push heat into the heat sink a lot more efficiently, as well into the heat block. And down in that break, you have that stainless steel tube that's very thin, and it won't be able to transfer heat very well. All the heat's going to stay in the copper, and you shouldn't have any issues with creep or anything jamming up down in here like you would in the stock setup. That's why this upgrade could help your print experience greatly. So those are the kinds of issues that you're going to see on your Creality style 3D printer that this upgrade is going to fix completely. You shouldn't see any of this going forward after this mod. Now, it has been 24 hours, so let's continue with our setup. We'll heat up and get our nozzle tightened. So I've set the nozzle temp to 250. We're up to temp. I'm going to go ahead and torque that nozzle one last time. I use the Olson Ruby Torque tool. You can get this a couple of different places. This is 1.5 nanometers. And that's usually pretty good on most nozzles, but check with your manufacturer. But I'm just going to hold that heat block once again with some pliers, and we'll just torque that until it clicks. I have switched out the stock nozzle tool. It comes with a 7mm socket for E3D. I just switched to a 6mm to use on the Creality style. But that should be good. We're torqued. And now we can go ahead and put our sock back on. Now you might want to consider running a PID tune. I will leave a link on how to get that done because you have changed your thermal mass just a little bit. With that new break being copper on the top of that heat block, it might change it just a little bit, probably not enough to matter, but it never hurts to run through one. So let's start a print with our new upgrade and see how we do. Now that you've made your upgrade, you do need to tweak your slicer just a little bit because you saw in that break, if you were to pull it back the same distance as you usually do on retraction with that PTFE liner on this Bowden setup, you might pull the filament back into the cold side of that break, and that could cause a lot of issues. So you definitely want to reduce your retraction. So I usually have this Ender 3 style or Creality style setup set at 5mm for my retraction. I'm going to reduce mine down to 2. That should be a low enough value to keep that filament out of the cold side of that break. It does have an added bonus that it will give you a little bit more speed. It will decrease your print time a bit depending on the model. And this upgrade could potentially increase your flow rate, but with just upgrading the break, I wouldn't even consider that at this point. I would just take it for you don't have to deal with the usual issues that you see on the Creality machine with that PTFE liner. So now we can slice and do some printing. So the tests are complete, and the bed testing model that I was trying to print before, I was trying to test adhesion, completed successfully, no issues whatsoever. But talking about retraction, I also wanted you to see some of the results if you don't adjust it. This is the stock 5mm that I would use on a PTFE liner. You can see it didn't fare very well with that all-metal brake. This is a setting of 1mm. You get some inconsistency there, it's not quite enough, and it is fairly stringy. This is 2.5mm, we're getting pretty close, and I settled with a 2mm. Now, this plastic, I probably could have reduced the temperature just a little bit to get it even better, but maybe just a little bit more dialing in. But 2mm is going to be more than acceptable for a lot of prints. So there we go, our upgrade is now complete, and for 30 bucks, that's going to give you a lot more reliability out of your Hotend on the stock Creality machines. Now, I did make this video just because I wanted to try this brake modification myself, just to see how much better it performed. And after watching Chuck and Stefan's videos, I definitely had to give it a shot. And I've been running them for a couple of months, and I've had no issues at all. The biggest issue I always have on the Creality machines is this under extrusion. You have to mess with that PTFE tube. And I didn't want to do that any longer. So I thought this might help a lot of folks out. Plus, we break it down in the traditional Chris's Basement way. So hopefully you found this helpful. That is it for today, and I'll see you really soon on the next one.